Okay, so it's a great pleasure for me to introduce Daron Acemoglu here to give us this keynote speech. I wanna thank Raquel and Chico and Claudio for this opportunity and also for putting together this Lacea virtual meeting under very challenging circumstances. I think we all can relate to that. Usually when we're introducing speakers in these types of keynote speeches, it's common to say that the speaker needs no introduction. And I think this is actually one of the very few occasions when this is quite literally true, right? So Daron has made major contributions to various areas, including but not restricted to labor economics, political economy, economic history, growth, technological change, networks, macroeconomics, among many others that some people might not know, but even operations research. So he has been at MIT since 1993. Since 2019, he's been the MIT Institute Professor of Economics, but he previously held the Charles Kindleberger Professor of Applied Economics Chair and also the Elizabeth and Jason Killian Professor of Economics Chair. He has really far too many awards and honors for me to list here. I'm gonna just name a few. He is the 2005 winner of the Clark Medal from the American Economic Association. He was elected a member of the National Academy of Sciences in 2014. He won the Sherring Rosen Award for outstanding contributions to labor economics from the Society of Labor Economics in 2004, a little, I guess, roughly 10 years after his PhD. He has a very large number of honorary doctorate degrees from universities around the world, and also various university awards, including the Schultz Prize and the Nemers Prize, given respectively by Chicago and Northwestern. In the midst of all of this work and accomplishments, Daron actually has found time to write some very influential books together with James Robinson. I think everybody in this audience knows about them: The Economic Origins of Dictatorship and Democracy, Why Nations Fail, and more recently, The Narrow Corridor. These books have been extremely well received in academia and also very successful with the public at large, I guess particularly the Why Nations Fail, and have also received numerous awards. Daron has some connection with Latin America. He has written on Latin American political economy, particularly on Colombia political on political economy in Colombia, with a large set of Colombian co-authors. But today, actually, he's going to be talking to us about tasks, automation, and the labor market. Daron, it's really a great pleasure for Lacea to have you here with us. We hope next time around we're going to have a chance to hear in person. And the plan is to have 50 minutes to an hour of presentation without interruptions. And I ask people to please send me the questions by chat, and we are going to have a 20 to 30 minute Q&A afterwards. So Daron, the floor is yours. I guess the screen is yours, right? And
thank you.
Thank you so much.
Thank you, Rodrigo. And thank you for that wonderful introduction. And thank you to Raquel, Claudio, and Chico, as well as to Rodrigo for inviting me. It's a great honor to be invited to give one of the lectures of Lacea. And having participated in Lacea conferences before, I know it's my loss that this is in the virtual form rather than in person. So I hope I'll have an opportunity to be there in person for one future occasion in the post-COVID world. Today, I'm going to talk about tasks, automation, and the labor market based on joint work that I have been doing with Pascual Restrepo from Colombia over the last 6 years or so. The reason why I have selected to talk about this topic is twofold. First of all, Pascual and I are super excited. We think there are some very important ideas that we would like to share with many people, including the Lacea audience. But also, secondly, I think the issues of automation, both in the industrial processes and increasingly in algorithms in AI, is something that has transformed many labor markets and its implications for emerging markets are sweeping, but have not received as much attention. So I want to talk about both the empirical and the conceptual issues that are involved here, but also touch on the policy issues that I think are relevant for Latin America. But for the most part, I'm going to use US data because that's the one that I have used in much of my work and understand better, but I'll touch on data from other countries as I go along to show you that this, what I'm talking about, is a pervasive phenomenon. The most important event, perhaps, in labor markets of the last 30 years, I'm going to argue, and something many other labor market trends are related to, is the shifts against labor. So after being roughly constant for about 100 years, the share of GDP or national income that goes to labor has been in steady decline. So the aggregate labor share in gray is shown there, and since 2000, it has fallen by about 7 percentage points. And it is not a compositional effect. If you look at the red curve, which holds industry shares constant, actually the decline, especially from the late 1990s, is actually larger, about 10 percentage points. There are many explanations for this phenomenon, and I think it deserves even more attention. Capital deepening, markups, monopsony, and all of those might have played some role. Some of them definitely have played some role. But Pasquale and I have argued that actually the main driver, and that's what I'm going to try to convince you of, is the changing task content of production. So I will define what I mean by the changing task content of production and try to convince you of how to think about it and why it has been so important. But first of all, before doing that, I want to argue that the implications of this change have also been quite momentous. So this picture is well known to many of you. It's one facet of the changes in the wage structure in the US. And again, there are similar trends in the UK and several other advanced economies, as well as in Latin America. But it is a striking picture, and I want to argue later in the talk that this is actually intimately linked to the changes in the labor share as well. So what you see here is 10 demographic groups, men and women, by 5 education groups, going from those with postgraduate degrees all the way with high school dropouts. And what you see is that up to the mid-1970s, from 1963 onward, if you look at real wage growth, it's been very shared. This is the period of a rising tide lifting all boats, and in fact, it was true in the 1950s as well, if you extend these series using other data sources. But from around late 1970s, early 1980s, they have a very different picture. You have a huge fanning out of wage gap opening between high education and low education group, both for men and women. But even more consequentially, you see that from this point onwards, all the way here, you have a significant decline in the real wages of low education men. This has had various sweeping implications, not least related to the social discontent and the political backlash that we have seen in many parts of the US, and again, in many other countries as well. Labor economists have been aware of these changes for at least 3 decades and a bit longer. But the way that they have been thinking about this for quite a while was based on the skill bias technological change view, which is that we've had new technologies that are favoring skilled workers, and this is the reason why inequality is opening up. There are many reasons why that framework is not very good, I will argue. One of them, which I'll come back to again later on, is that skill bias technological change, if it's really an acceleration in skill bias, shouldn't lead to a decline in real wages. More technology always makes everybody better off if it's really taking in the standard skill bias technological change form or factor augmenting form. So I'll come back to that in a second. But even more importantly, the evidence, which was perhaps early on not completely inconsistent with skill bias technological change, hasn't been very favorable to the skill bias view. So this is a figure from my work with David Otter What it does is that it shows you in the US for 3 decades, 80s, 90s, and 2000s, change in the employment shares of different occupations ranked by skill. And you see that in the red curve in the 1980s, the more skilled occupations were the ones that were expanding in terms of employment. So that would be consistent with technologies favoring skilled workers. So there is greater demand for people who are working in engineering, management, and other design-based occupations, which are perhaps being helped by skill-biased technologies. But the picture in the 1990s and 2000s looks very different. In the 1990s, you have a U-shaped pattern. So the middle occupations are being hammered, and the bottom, very low skill occupations, as well as the top is expanding. And in the 2000s, the middle is being hammered, and there isn't even much movement in the top, and only the very low skill occupations are expanding. So it looks very different from a skill-biased technological change. This actually is not just a US phenomenon. It is quite common across many, many countries. For the OECD, especially, we have the data, so we can look at what's going on across occupations again, now classifying it a little bit more coarsely into 3 groups: middle class occupations, and the lowest paying blue, and the highest paying occupations, the third. So the middle class occupations here are those that are the equivalent of the middle here, and they are the middle class jobs, factory jobs, blue-collar jobs, clerical jobs, administrative, sales, and such occupations. And you see that pretty much in every country for which we have data, the maroon red bars are heading south. Those occupations are disappearing, and they are being replaced either by low-paying or high-paying occupations, depending on which country you look at. So we have something that at least requires more thinking. So this is the background to the conceptual structure I'm going to introduce. So as a theory, I'm going to argue that we have to think about tasks and automation much more seriously. And it's going to lead to a very different way of thinking about production structure and about the implications of technology and about why inequality is increasing, as well as different types of remedies for it. I'm going to show you that this framework is descriptively more interesting and more realistic, and it's going to have different comparative statics. And I'm going to emphasize how changes in the labor share are critical. I'm also going to talk about why things have been different recently relative to the past, and I'm going to emphasize especially the role of new labor-intensive tasks. And I'm going to link all of these to inequality. Empirically, I'm going to try to back up all of these trends, so let me not preview that and just jump into it. So let me first start thinking about in terms of what the conceptual framework is. So if you're going to take anything away from this lecture and remember it, I hope a few things, but if there is one thing, I want you to remember the next few slides, which is that essentially the way that we typically think of production and technology is actually unsatisfactory. And the reason for that is because A, it lacks descriptive realism, and that really matters. I won't go into a methodological debate, but I think to say that, as if we can do it, not the descriptively realistic, but some as if representation is often something that will lead us astray. And here, there is really a complete lack of realism in the models that we use. If you look at the data, almost all of the iconic technologies of the last 300 years don't look at like anything we have in our models. They are machines that substitutes for human labor in a set of well-defined tasks. That's what horse-powered reapers and harvesters and threshing machines did in agriculture. That's what machine tools did starting in the second half of the 19th century. That's what industrial robotics, welding machines, assembly line, packaging do. Software and algorithms do that for white-collar workers, as well as other technologies, which I'm going to talk a lot about, which change the organization of production, adding new tasks that did not exist before. This doesn't map in any shape or form to the frameworks that we teach in graduate schools. And mea culpa here, if you look at my growth Introduction to Economic Growth book, it's all based on this production framework. That was written in 2008. And since then, I have become more and more dissatisfied with that framework. at the time I would have justified it as an as if framework. It's a good representation, but it's not a good representation. It doesn't capture that tasks that are done on the floor. If you want to produce a piece of garment, you have to do spinning, weaving, coloring, dyeing, knitting. All of these tasks have to be completed, and production is really about the completion of these tasks. It doesn't really naturally map into this framework. But more importantly, when you represent technology like these blue terms, the labor augmenting AL and the capital augmenting AK, it gives a very specific way of thinking about technology. In particular, it implies implicitly that technological change makes tasks uniformly more productive. Factors uniformly more productive at all tasks, does not create major substitution effects, and tends to create this sort of productivity boom for all factors of production. Instead, I'm going to argue that we need to think about the task content of production. For now, this is just, imagine this as like a latent variable that was missing in the way that we are thinking about it. It's a latent variable that's critically affected by such things as automation or reorganization of production. And now I'm going to try to give you a way of thinking about it. Okay, so let me, before showing you the math, let me actually show you the figures. Actually, no, let me show you the math and then the figures. There was a reason why I organized it this way. So here is a very simple way of capturing these ideas. This is a very parametric way of capturing it, but I've chosen it, Pasquale and I have chosen it to make it as tractable and as similar to existing frameworks. Imagine output is produced by combining tasks across a variety of tasks. I have normalized them to a measure 1, and for reasons that will become clear, I run the limits here from n-1 to n. And I am assuming, Pasquale and I are assuming, that these tasks are combined with an elasticity of substitution sigma. The key aspect of this framework is here. These tasks can be produced by capital or labor. There is comparative advantage, meaning that capital and labor have different productivities in different tasks. There is a technological possibilities to create new tasks. And also there is something we're going to call automation, which is that tasks that were previously infeasible to produce with capital can now be produced with capital. So namely, these tasks which go from some threshold I to some other threshold, the limit threshold n, cannot be produced by capital. So all you can do is assign some amount of labor. Labor has some productivity gamma LZ in this task Z, and then I'm allowing this labor augmenting AL term because because I want to nest the factor augmenting technologies into this framework. Now, some tasks, and in particular here, those below I, can be produced by capital. So they are technologically automated, which means that capital and labor with their different productivities are perfect substitutes. The fact that they're perfect substitutes is not important, but there needs to be a high level of substitutability because you're replacing those tasks that were previously performed by labor by capital now. And for capital, you have a different productivity gamma K. And again, I'm allowing for this capital augmenting term as well. The comparative advantage is that higher index tasks are better with labor, lower index tasks are better with capital. So now let me give you the diagrammatic representation. This is the space of tasks. And what I am plotting here is the cost of production. So for the blue line, this is the cost of production using labor. So what is the cost of producing 1 unit with labor? Well, it's the wage divided by the effective productivity of labor in that task, AL times gamma LZ. And the orange line is the cost of producing the same task with capital, but only those below I are feasible to produce with capital. So I've only put the orange curve on that part. So if you wanted to cost minimize and there were no other constraints, you would choose this allocation of capital to labor. So now what is technological change? This is what labor augmenting technological change looks like. So literally, if you buy this framework or anything similar to it and say, what have we been assuming all these years since, neoclassical growth theory, going back to Uzawa, Solow, Harrod, and so on? We've been assuming that technological change makes labor uniformly productive in all tasks. So that curve shifts down in a parallel fashion. And if you wanted to do capital augmenting technological change, the capital one would be shifting all the way down. Now, again, I don't know of anything that looks like this in practice. Instead, in a range of tasks, the productivity of labor may change. In a range of tasks, the productivity of capital may change. Those we have seen in history. But many things look like this. This is automation. So we extend I to I prime. And as a result, now we can produce these tasks with capital, and this is the productivity gain. So not this productivity gain, that's huge, because all tasks becoming are more productive. No, a much smaller productivity gain that depends on the gap between labor cost and capital cost in the tasks that you have automated. Or you can do a reorganization of production and add new tasks. That could be quite important, and we'll see this in practice. Okay, so now that I have given you this illustration, let's solve this model. Of course, I'm not going to go through the algebra, but the algebra is not very challenging because this is, a CES-like structure, so it's pretty easy to work with. And when you solve the model, it looks like this. We can write a representation of output as a function of capital and labor, so it looks like our classic production function. And in fact, the AK and AL come in the labor augmenting form. That's how we introduced them, so that's no surprise. But critically, there are these new orange terms. Instead of the distribution constants that you sometimes write, and sometimes most of the time you suppress when you write a CES production function, we now have an endogenous terms that guide how tasks are allocated to labor. And if the labor share in this economy is given by this expression, and this is actually pretty insightful because it shows that there are two separate effects on labor share. One is the classic one where elasticity of substitution, factor prices, and factor augmenting technologies come in. It's in blue. I'm going to explain to you in a second why it doesn't actually matter much in practice. And then there are these orange terms which come from here, from the automation and new tasks. And that matters quite a bit. And it works independently of the elasticity of substitution, because it's not about the substitution of labor at the intensive margin. It's the substitution of machines and tasks at the extensive margin. And the fact that I can write this in this separable orange and blue term highlights that these things are almost separable. They're really quite two distinct things. And the orange one is typically what we have ignored in our models. So this term, gamma and I, this task content term, looks a little bit complicated. But actually, if you take sigma to be 1, or if you take these task productivities to be constant, then it is simply n minus I. It's just the range of tasks allocated to labor relative to capital. Now, one result is immediately clear. If you want to think about factor augmenting technologies or changes in factor prices that come from other sources, and you want to think about their impact on labor share, unfortunately, you have to think about this elasticity of substitution. When the elasticity of substitution is above 1 versus below 1, everything flips around. That's always been an annoying feature. I never had a good intuition for it. But part of the reason is because it's actually not very realistic about how technologies work. Instead, if you look at n minus I, that always works independent of the elasticity of substitution. In particular, automation always reduces the labor share regardless of the value of sigma, because it takes away tasks from capital, the labor gives them to capital. What about the overall labor demand? Well, as I promised, I'm going to show you that all of those effects actually work through the labor share, through this expression that I just gave you. And to do that, in particular, let's look at the labor share and and write one measure of labor demand, wage bill, as output times the labor share. That's just the definition. Then any effect of technology on labor demand or the wage bill is going to be its impact through these two terms. So in particular, let's look at automation. The impact of automation on labor demand can be decomposed exactly into these two forms. One is a productivity effect. It depends on how much gain we have by reducing costs, which is just your productivity improving. So if nothing else happened, that would be the only thing. And since I'm looking at logs, that would be just a neutral change. Production becomes more productive, the labor share remains constant. But in fact, there is a first order displacement effect working exactly through this gamma term, which is that we are taking tasks away from labor and giving them to capital. That's always negative. Which one is larger? You cannot know. So with factor augmenting technologies, they always benefit factors because they're making factors more productive. But it's no longer true once you go to the task space and think about automation. In particular, the displacement effect can be smaller than the productivity effect, and you have a more neoclassical impact. But that requires the productivity effect to be large. On the other hand, this is what Pasquale and I call so-so technologies. They're not that great, like checking self-checkout kiosks. Who thinks self-checkout kiosks are going to revolutionize production? Well, if they are like self-checkout kiosks, this is not large, it's small. And if that's small, the displacement effect is going to dominate. You have productivity increases, but wages get hammered. What about factor augmenting technologies? They don't have any of that displacement effect. So that's why the productivity effect really tends to dominate, especially for realistic value of sigma, which is estimates that are comparable to what we have here are about 0.7, 0.8. This term is going to be very small. So they're just going to have a productivity effect. So they're going to be, oh yeah, everybody benefits, great, we are technologically more productive. But that's not what the data is going to show in a second. If you have new tasks, then you have a double whammy for labor. The productivity effect helps labor and it could be very large, but you also have what we call a reinstatement effect. That's always positive because you're adding new tasks that are labor intensive. Okay. So now, with this in mind, let's look at the data. So this is how the labor share looks like in the US from the end of the World War II to the 1990s. And I have, Pasquale and I have put things together into a number of sectors that are easy to interpret: manufacturing, construction, services, transportation, mining, and agriculture. This is maybe a little bit different from some other data you have seen because it's very important that you do everything for value added. Sometimes people report labor share in sales or revenue. That doesn't really correspond to production theory because you have the intermediate inputs and they are changing. So if you do things in value added, you know, the labor share is very stable. The only sector that shows a significant decline in labor share is mining from 1970s onwards, and that's a small sector. But the picture is very different from 1987 to 2017, but mostly because of manufacturing. You have an over 15 percentage or 14 percentage point declines in the labor share of manufacturing. A small decline in construction, services mostly constant, some decline in transport. But it's really driven by manufacturing. So a lot of that, of what I showed you at the beginning, is really about manufacturing. So what's going on? Here is a different way of looking at it. These are scatter plots for 60 industries, and here I'm zeroing into some subset of manufacturing industries that are much more detailed. And what you see is that there is a strong association between industries in which you have labor share declines and measures of automation. So this is somewhat coarse because we only have it for broad sectors. Penetration of robots. The more robots are introduced, the more labor shares are declined. This is with the share of routine workers, so that these circles, which are the non-manufacturing sectors, also have some degree of automation, the algorithmic or database or clerical automation. So you see the more automation possibilities there are, again, the more labor share declines. And here zeroing in onto specific manufacturing sectors, those that are using automation technologies are showing more declines. On the other hand, things that look like new tasks, for example, emerging skills, new skills, or the diversity of tasks in workplaces expanding, they have greater labor shares. So this is exactly, again, it's not a proof, I'm just showing descriptive evidence for that. This reinstatement effect implies that when you add new tasks, not only you increase labor demand, but you're actually increasing the labor share. So now what I want to show is actually go a little bit more into the data and try to show you what micro technologies do at the micro level. So I'm going to do that at the local labor market for robots in the US, and then I'm going to do it for French data using firm level data. So to do that, let's look at a measure of exposure to robots that Pasquale and I have built. And essentially the idea here is very simple, that we are looking at how the frontier of robots technology is changing across different industries. That's what we call adjusted penetration of robots, or robot penetration in industry I. And then we look at how much in a given area there was employment in that industry. So this creates our exposure to robots measure. And now I'm going to show you what happens across 722 local US labor markets when you have greater exposure to robots. In all of these regressions, there are a variety of other controls for demographic structure, imports, and all sorts of other things. So this is a fairly robust patterns that I'm showing you. I'm not going to go into the details, but I want to illustrate a few facts. So this just is a reality check. Exposure to robots, as I've measured it, predicts robotics activity at the local economy, for example, local robot integrators. But what I really want to show you are these two pictures. This is exposure to robots and local employment, a strong negative relationship. And this is exposure to robots and local wages. Both of these, again, are rather challenging if you have a very neoclassical view. You have robots, which are some of the most productive technologies of the last 20 years in industrial production. But where they are introduced, you have huge declines in employment and significant declines in wages. So if you look at this, either of these two pictures, this is the industrial heartland of the United States. Places like Lansing, Detroit, Flint, Wilmington, Toledo, Ohio, etc. So these are not driving the relationship. If you leave them out, if you leave all of those out, you get the dotted line, so which looks identical to the solid line. But they are emblematic of what's going on. These are the places which were on a perfectly parallel trend with the rest, but then once the robotics technology comes in, these industries are flourishing, but the workers that used to be the frontline workers are being hurt. Are we sure it's the frontline workers? Yes. Where are the negative effects? They are being driven by routine manual occupations, operatives and assembly workers. Exactly the workers that used to do these middle class occupations before. So a recap, you have these local labor markets that were on parallel trends before the 1990s, and then the robotics technologies comes, these technologies, these industries are booming, but wages and employment fall for these workers. But this is at still a macro level, local labor market level. So I want to now turn to what happens at the firm level. So this is now drawing on more recent work with Claire Lelarge and Pasquale Restrepo. With Claire's amazing work, we've put together, which I think is the only or the first comprehensive data on robot adoption, and for about 56,000 manufacturing firms in France, using 4 different data sources to create a comprehensive systematic data. Only about 1% of firms purchase robots, but they account for 20% of manufacturing employment or value added. It's the larger firms that adopt robots. So this is, you see the share of robot purchasers among the top 0.1% is about 20%. Among top 1% is about 15%. But if you go to the bottom half of the employment distribution, it's essentially 0. And it's much higher for the high average penetration of robots industries that I had pointed out earlier on. So let me run the following regression now at the firm level. Some firm level outcomes. I'm going to look at 3 of them. I'll show you in the next slide. I'm going to look at whether the firm itself has adopted robots, but I'm also going to look at its competitors, which are firms in the same industry, and if this industry is non-tradable, it's also in the same local labor market. And here are the results. Let me actually start with this one here. And let me just focus on the unweighted ones, it's the same. If you adopt robots, you are going to experience a significant decline in the labor share, exactly like what I was showing you in the manufacturing. So in France, the labor share decline is less than the US, and I'm going to show you in a second that it's in manufacturing, it's essentially accounted for by these robot purchases. So a robot adopter has a 4 to 4.5% decline in labor share. What happens to employment or log value added for these firms? They actually expand. So firms that are adopting robots expand. So it looks different than the local economy effects I showed you a second ago, but that's because these firms are essentially the ones that are reducing their costs. So what happens to their competitors? If you look at their competitors, you have a huge decline in their employment. So if you are adopting robots, you are expanding, but at the expense of other firms in the industry that are contracting. And if you turn the sum of these 2 effects into a net effect, what you find is that it's in the ballpark of the negative effects that I've shown you before. Now, robot adoption is associated with these labor share declines. Let's put that into a context. And to do that, let me follow a decomposition that a recent work by Outer, Katz, Patterson, and Van Reenen and Daron has proposed. And they decomposed change in labor share into a within firm change in the unweighted mean of labor share, and then what they call a superstar effect, change in the covariance between the labor share and value added. And they interpret this, they find that this in the US, the superstar effect is large, and they interpret this to do with markups or firms becoming more capital, or some capital intensive firms expanding. I'm going to show you the same pattern in the French data, but a very different interpretation. So this is their decomposition applied to French data. In fact, the patterns are even starker in France than they find in the US. If you look at firms that do not adopt robots, they actually expand their labor share in France. But firms that adopt robots have a decline in their labor share. And the aggregate is accounted for this superstar effect. But where is the superstar effect coming from? Well, it turns out that it's really coming from to reallocation to adopters of robots. So it's really largely about robot adoption. It is that it's not that these firms are different ex ante, it's just that these firms are large, they expand quite significantly when they adopt robots, and at the same time as they're expanding, they're reducing their labor share. And that's what accounts for the superstar effect, or 70% of the superstar effect. So I don't know the same in the US. We can do that now because we've collected census data for a very large sample of firms in the US that we will be able to analyze in the next year or so. But if this is true, it's a very different interpretation, again, related to this task structure. Now, the last topic that I want to touch on is inequality, because I announced at the beginning that this isn't just about capital versus labor, but there is also a first order explanatory role of these changes for the huge transformation of the wage structure in the US. So let me first show you what happens if I do the same exercise as I did with the US, or Pasquale and I did, with the local labor market, but now looking at employment and hourly wage differentially by education groups. And what you find is that the negative employment effects are concentrated in low education workers, much less on college graduates, no negative on postgraduates. Even more clearly, if you look at it by percentiles or quantiles of the wage distribution, you see that the negative effects go all the way to about 65 percentile of the wage distribution and nothing after that. So at the aggregate, you can see that automation has been inequality expanding. But this actually doesn't capture the full impact of automation, because again, I'm just focusing on one of a suite of automation technologies, none of the algorithms, none of the numerically controlled machinery, none of the office automation. So to do that, let's expand the framework that I presented before, where tasks are allocated to capital and labor, now introduce many different types of labor. It's the same, except that now I have many different types of labor that goes from G equals to 1, 2, 3, 4, 5. Other than that, it's the same framework. What that implies is that now I'm going to have, instead of intervals which were allocated to different factors, sort of multidimensional objects. So task space is going to be divided into sets that are allocated to different factors. So visually, if I have just two types of labor, high and low, for example, the task space is now going to be allocated to some of it to capital, some of it to low, some of it to high. And then the effects of automation will be, well, depends on where automation is expanding, but imagine if automation is expanding into the tasks that were previously performed by low-skilled workers, then you're going to have this type of expansion. Now, then you're going to also have general equilibrium effects, which we typically ignore, but could be quite important because they're going to be ripple effects. Once these tasks are taken away from low-skilled workers, now they're going to start competing more with each other. They're going to perhaps start competing with high-skilled workers and so on and so forth. So now this framework can be turned into an estimation equation under some relatively weak assumptions. And since time is short, I don't want to dwell on them very much, but essentially, the two assumptions are that I'm going to assume markups are constant. They're not going to change. There can be markups. There can be imperfections in the product market. And I'm going to assume that automation impacts routine tasks in any industry, and workers doing that routine tasks are all going to be affected the same way. That's a simplification. Claudio and I may be both doing the routine tasks, but he's more skilled than I am in some ways, so he may be affected differently. We're going to take those into account as well. We take them into account in our work. I'm not going to present that. Those will be part of the ripple effects. The ripple effects might work differently for me and Claudio. But if we are both doing a particular task and that task is automated, the first order effect is going to be similar both on me and Claudio. So that's not a bad assumption. So under these assumptions, we can represent the impact of automation on a demographic group by how much automation is ongoing in the industries in which they are working and performing routine tasks. So the idea is Raquel is in a different demographic group than I am. If I look at Raquel's demographic group, there may be a lot of workers in Raquel's demographic group who work in finance. Finance is not being affected by automation. There may also be a lot of workers in Raquel's group in textiles, but they're not doing the production tasks in textiles. Again, they're not going to be affected by automation. But if Claudio is in a demographic group that a lot of people like Claudio are working in auto manufacturing and are doing the welding or the assembly jobs, they're going to be affected by automation if it's ongoing in car manufacturing. So here is a look at that by a very descriptive way. So what I'm doing here is that I'm simplifying things. I'm assuming Cobb-Douglas technology here just for simplicity, just to get a clean graph. And I am creating demographic groups by education, 10-year age bands, gender, and race. Each dot here is a demographic group, but I have highlighted the education of the group with a different shape. So this is the effect of task displacement between 1980 and 2016 for that group. So how much they are taking place in industries for which we say there is a lot of task displacement, and how much routine jobs they are performing. And what you see is that groups such as those with less than high school that tend to be in industries doing routine tasks that underwent a lot of automation are those that have experienced negative wage growth, and those that are not affected by displacement have had positive wage growth. But again, you might be worried about lots of other things. So let me put this in a regression framework. 1 second, just sorry. Sorry about that. So let's put this into a regression framework. So what I was showing you earlier on was this variable. So hourly wage between 1980 and 2016 has a very strong negative effect on the wage of the group that's being affected. But more importantly, this has nothing to do with sectoral effects or whether your sector is expanding or contracting. It's really about whether you are specializing in routine jobs in sectors that are undergoing automation. So you can control for all of the main effects, the interaction, which is through automation or through routine tasks and automation, remains the same. What about skill bias technological change? Well, one way of dealing with that is to allow completely flexible trends by education. So this is an overestimate of skill-biased technological change, because you're saying let all education groups, all of the changes that are common across education groups, be assigned to skill-biased technological change. So that's what Pasquale and I do here. And if you do that, what you see is that all of these education interactions don't matter much, except for people with more than college. But the low education, college, etc., none of that matters. Gender matters. So there is something to do with gender that's other than task displacement. But the task displacement variable doesn't change from what I showed you earlier on. And if you do an adjusted R-square comparison, the partial R-square of task displacement is about 40%, and that of this overestimate for education, SBTC, is no more than 16%. So what this says is that these routine jobs being displaced by automation technologies working through labor share is much, much more important for inequality than we might have presumed so far. And the evidence for SBTC is even thinner than you might have imagined. Summary. What I have tried to do is provide a new and richer perspective on wages, employment, and inequality, starting from the task building up to labor markets or firm level outcomes. I have tried to argue that this framework is very different, both in terms of its implications of what technology does to wages and employment, when it affects labor share, how we should think about technology affecting productivity. But it also provides new perspectives on what's going on with labor share and why it's changing, where it's changing, in what firms, in what industries it's changing, in particular its role of automation in that. And it also, through the labor share, has first order implications for inequality. But what determines automation, and what are its implications beyond the US or advanced economies? Well, that's my last slide. Unfortunately, if I had time, I would speak for another hour, because a lot of my work actually is about this, what determines automation, and some of my new work is about its implications for developing economies. But instead of doing that, let me just summarize the ideas. I think the perspective that comes out of this work is that there are two phases of automation. Good automation is what we have experienced for decades in the US economy. There was a lot of automation in the US economy in the 1950s, 60s, and 70s, but it went hand in hand with other technological changes. And that's the reason why when I showed you the labor share across different sectors, it was constant. If you look at more micro, you would see that labor share was increasing in some industries, declining in some industries, and they were counterbalancing each other. But there's also another phase of automation, that's bad automation or so-so automation. It's almost, you can call it excessive automation. Policy distortions, visions, the effects of big tech or whatever, we can get into the details. Again, that's some of my work, but I'm not going to have the time to do it now. When that happens, it doesn't bring much productivity gain. It leads to these big declines in labor share. It may be inefficient. Again, I don't have time to go into it, but you can see why that would be the case from the basic framework I have presented. And then that's the case, it's also destroying jobs. It can be counterbalanced with new tasks, but if our technology policy is going automation, 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 we are not doing enough new tasks. So the future of work in the US and in advanced economies is very much about this balance. If we go for ceaseless automation and nothing else, it could be very costly, and it will be a continuation of the last trends that I showed you, labor share declining, inequality increasing. If on the other hand, we go for these new tasks and good automation, it could be a brighter future for labor. It could create good jobs, it could create high wage activities, labor share doesn't need to decline. Now, what about the developing world? Well, actually, the developing world is a double whammy. Countries such as Mexico, India, Colombia, Argentina, Brazil are not at the table. They are not deciding which type of automation the US or Germany or Switzerland or China will adopt, but they are very much residual claimants of these decisions. Why? Because even though if you look at robot adoption rates or other technology adoption rates in Latin America, they're not very high. They're going to get higher, but more importantly, it doesn't matter that they are not adopting it, because the global division of labor is affected by automation. So if you look at what happens to companies that introduce robots, they offshore less. So Mexican auto part suppliers supply less to the US when auto producers in the US automate. So through the endogenous changes in the global division of labor, Latin America and other emerging economies are already being affected. And they will continue to be affected even more, especially with AI. But here is the catch. And this is the point that some of my new work is getting into, and I'm happy to answer it and discuss more about it in the Q&A session. From the viewpoint of Latin America and the emerging world, automation-biased technology is an inappropriate technology. Why? Because emerging world is still abundant in labor, and what is automation doing is saving on labor. So even though Brazil, India, Mexico are not at the table, there are many consequential technology decisions, and they're going very much in the direction of classic inappropriate technology. US decides the technology, consequences are felt in Latin America. So I think that's going to be a defining challenge for many emerging economies in the decades to come. And that was part of my motivation to introduce this topic, although, as I said, I didn't have time to talk more about the emerging world. So therefore, one question is, which future will it be for the US? But in the same breath, we have to say, which future will it be for the emerging world as well? So let me stop there. I think that's exactly the 55 minutes that Rodrigo had given me. So I am looking forward to answering your questions. Thank you.
Thank you, Daron. Thank you so much for this very, very interesting talk, and presenting also your work with Pascual, so one member of our region. And very, very interesting. We already have a couple of questions. Actually, it's kind of nice because we had an early discussion between Luis Fox and Raquel here in the chat, and they actually go in that exactly in the direction of the very, very last point that you made, which is basically the issue of endogeneity, and I think also a little bit related to some of the regressions that you showed in the end, right? The issue of endogeneity of technology adoption and how cost of capital and actually, I guess, cost of skilled and unskilled labor supply also may affect that. And in some sense, the way it actually, I think it's a slightly different perspective. I think the question, if I understand correctly, and Luis, please correct me if I'm wrong. The question more being from the perspective of technology adoption in developing countries, that the relative cost of capital and skilled and unskilled labor may actually be an incentive for less technology adoption, right? To delay technology adoption. Mm-hmm. And I think there is like a side issue to that question that Raquel raised, which is kind of an empirical issue as well in terms of part of your analysis of the endogeneity of technology adoption within some of the empirical results. So since you were mentioning this topic in the end, I think it would be nice if you actually extended a little bit this discussion, and then I can come back to the other questions.
Yeah, so I think there are two important elements here. One is that even if Latin America, for example, to give a specific instance, did not adopt the technologies that are developed in the United States or China, it would be impacted because of the changes in the global division of labor. So think of the classic model of emerging economy growth that, sort of we have at the back of our minds, like South Korea or Taiwan. You specialize in, you start with low-tech manufacturing, you export them because manufacturing is the easiest one to export. And then you move up the value chain. That's essentially what China later emulated and was very successful at it. Well, that strategy is not going to be available as automation becomes more and more widespread, because you're not going to be competing against workers in Germany or the US, but you're going to be competing against robots and numerically controlled machines and algorithms in the US. But then there is the effect that those technologies, many of them will be adopted in Latin America as well. That's partly because it's the same companies that are part of the multinationals that are operating in every place. They are setting the scene. They are creating standardization. So in the same way that capital-intensive agricultural machinery were adopted in the developing world, many of these machines would be. But then there's a third cost, which I think is the most important one, and that relates to this endogeneity point. When the US favors automation ahead of other technologies, it is reducing the rate of progress of other more human-friendly technologies that would have been particularly useful for the emerging world. So I think there's an endogenous technology channel that will have these effects spread throughout the world as well. Do we have evidence on all of this? No. The evidence we have is very small. It's a very nice paper that shows, for example, that Mexican suppliers are adversely affected by robot adoption in the US. And there's some work that we are doing on the offshoring decisions of robot adopters in France, for instance. But there's much more to be done here.
Okay, thank you. So I think I'm going to collect a few questions here, and then maybe you can touch a little bit on each one of them. So Lucas Ferrero has actually asked a little bit, he wants to hear something on market structure and how market structure may change with automation. I think he's wondering whether there might be an increase in concentration as you have more automation. I think, as we could imagine, that this will change returns to scale. Carlos,
yes. Should I answer them one by one, or how should we do it?
Okay, so go one by one. Yeah.
Okay. Well, that's a great question, and the evidence that we have so far suggests that's a real concern, but we need to do much more to look into it. So here it is. Let me go back to the French data. The robot adopters are the largest firms. It's a really steep gradient in terms of who are they, and they are expanding. That's what I showed you here, at the expense of the smaller firms. So that's indeed automation, at least robots in the French context. We don't have the same, but there's now a paper on Spain that finds similar things as well. So in the context of manufacturing and robots, indeed, there is a concentration effect. Now, it would be very interesting to look at the markup implications of this. So estimating markup with automation is not an easy thing. Why? Because most of the markup estimation assumes a production function like Cobb-Douglas that has constant factor shares, but I showed you that automation changes the factor shares. So I have new work with Nikhil Agrawal and Pascual Restrepo, sort of developing a framework for estimating markups in that. But we don't have results on that yet. But so we can look at whether this is actually increasing markups as well, which is an interesting question, but I don't know the answer to that. But I wouldn't be surprised if it is.
Okay, thank you. Carlos Madeira has also a very interesting question about how this may interact with population aging, may make it even harder for older workers, and the potential spillovers of that on the sustainability of savings and pension systems, right? I guess.
Actually, that's a very, very interesting question.
Yeah.
It's so interesting, and if you indulge me, I'm actually going to show you a graph.
Please do, yeah.
So it's a fantastic question. Thank you. Oh, sorry. Oh, man, sorry. I forgot where the slide that I wanted to show is.
That's okay.
But this is the relationship between aging and robots. So countries that are aging are adopting much more robots, and actually about 50% of the variation in the data across countries and industries is explained by aging. So it's a huge thing, but actually robots are really helping the older workers. And the reason is because they are actually replacing tasks that are performed by middle-aged and younger workers. And if you look at the wage effects by age, I have the slide here, but I'm not going to show it to you since I don't want to take more questions. But the negative effects are all on the middle-aged and older workers, and the older workers are actually benefiting from robots. So if retirement age is not very rigid, so it can be expanded, I actually think that robots can create even more gains, and some of the pressures on pension systems could be relaxed if they are adopted in a productive way. So that needs to be the good automation part, but if the good automation would be particularly complementary to older workers. And that's not a surprise, because robots are when they are adopted, they are performing some of the more manually challenging tasks.
I mean, I don't want to take the time from other
No,
questions,
please
but
do.
just to follow up very quickly on that. But this depends a lot on the what you call the reinstatement effect, right? I mean, if labor
No, this is without the reinstatement effect. I mean, in the data, I don't know. Theoretically, it's without the reinstatement effect. The reinstatement effect would come on top of it. But in the data, it's because older workers don't perform the tasks that are at the that are the ones that are being replaced. So look at this. Look at this is US data, but actually it's very similar across other countries. Look at people, but the age profile of people who are machinists, craft production, material handling. These are sort of the blue-collar jobs that are most at risk of robot replacement. You see around the age 55, you have a sharp drop. Older workers don't perform these tasks because they're manually very challenging.
But I think in some sense, the question is what's going to happen to this 30-year guy who's being displaced?
Oh, that's a big problem. Yeah, that is a big problem. That is a big problem.
I think that, yeah.
So, but, there you see the thing, and this is a blessing and a curse for Latin America. When you have the robot adoption going on in South Korea and Germany, it's not that damaging. Why not? Because they don't have many of these 30-year-olds. That's why they are at the forefront of adoption. Now, the blessing and the curse for Latin America is that Latin America right now is very young, but it's going to age very rapidly. So if the numbers that I have looked at, and I'm sure there are people who know this much better than I do, but the Latin American demographic transition is going to start late, but it's going to be much faster than the one of the US or the UK. So if Latin America can manage the automation process well, it could be a positive, but the big thing is it can manage well, and especially this inappropriate technology point. So there are a lot of conditionals here.
Okay, no, let's move on. I don't want to take time from other people. So we have another question here, Andres Giraldo, who is asking about, most countries have some incentives for firms to invest in capital and innovation. And he's asking to what extent these effects that we see are partly determined by tax structure.
Oh man, that's another great question. I promise you, I did not plant these questions, but since you asked, let me show you. That's another paper that Pasquale and I, with Andrea Manera, have written. So this is the US tax structure, effective taxes. The blue one is labor. The red one is software. The purple one is equipment. So in the 1990s, capital was favored in the US tax code. It was taxed more lightly. But since then, capital tax rates have been completely slashed, especially for software and equipment, the ones that are engaged in automation. Today, many companies actually would receive a subsidy from the government when they adopt a machine and lay off workers. So the US tax code is what Pasquale, Andrea, and I argue is one of the chief reasons for excessive automation. But then this has implications for the whole world. That's the inappropriate technology point again.
Okay.
And of course, economists have been cheering this on, saying, oh yeah, we should cut the capital taxes to zero. So that's another story.
Okay, thank you. So Claudio actually has asked about whether this adoption of new technologies in Latin America would take the same form that we see in more developed countries, right? That, I mean, the more mechanical part of it, like robots, and so robots are difficult to design and very costly. But there are other aspects of artificial intelligence, artificial intelligence and I guess programming more generally speaking, that are easier to adopt and require much less capital, right? And whether this might represent a difference in terms of these patterns that we are discussing. Claudio, feel free to jump in if you.
That's a great question, and the answer is I don't know. So algorithmic automation has been ongoing for the last 20, 25 years. But AI, true AI, is a very new technology. So Pasquale, David Otter, and Joe Hazel and I have a paper on AI, and if you look at it, it's just still too little of it in the US labor market. So true AI is an emerging technology. So we don't know what it's going to do. And that's actually important, because if you actually think of what AI is capable of doing, it's very varied. It could be hugely useful for increasing human productivity, or it could be an automation technology. So that's why some of these endogenous technology issues, are we pushing AI in the right direction? Who is deciding the future of AI? I think those are really first order questions. And again, not just first order question for the US, but for the emerging world. For instance, who decides the direction of AI technology? Well, certainly nobody in Brazil or Mexico, that's for sure. But not that many people in the US either. 2 out of every $3 of R&D spent on AI is accounted for about 6-7 companies. So about 7 companies are deciding the future of AI. So if indeed, as AI, if indeed as many are claiming AI is going to define every aspect of our lives, from consumption to communication to production to leisure, well, we're letting about 200 people in these 7 companies decide the future of humanity.
Well, that's a concerning fact indeed, and I think this actually may be linked back to the next question as well, which connects a little bit this discussion with your political economy work, I guess. So let me see, who is it? Henry Hapanala is asking, whether do you think there was a role in the decline of unions in the US from starting the 1980s, with the rate of technology adoption and introduction of robots and these changes that we have seen since then?
That's a great question, and I don't know the answer to that. The effects of unions is very complex. On the one hand, if you think of unions doing nothing else but pushing labor costs up, then they would encourage automation, because it makes it more attractive to substitute capital for labor, because labor has become more expensive. In cross-country data, there is a positive correlation between unionization and automation. Countries that have higher union coverage tend to automate more. What that means is not, like what the other stuff that I showed you is all very robust and it tries to exploit exogenous sources of variation, for example, on fertility rates on 40 years ago, etc. in the case of aging. So this is just a correlation, and I wouldn't, I don't know what it means. But I do know that the effects of unions is more complex, because unions don't just push up wages, they also regulate the organization of production. So there's recent work by Simon Yeager, my colleague, and Benjamin Scheufer from Berkeley, which shows that German companies that have workers in the boardroom, worker councils, actually automate more, but when they automate, they avoid the more negative effects of robots on wages and production workers, probably because of a deal between management and workers, or perhaps they select more productive automation. So there is clearly an impact of certain types of labor organization on what types of automation is ongoing, how fast it's ongoing, other aspects of our organization. And Germany may be best place to do this because workers are trained, they can be reassigned from the tasks that they were producing to other tasks. But those are just all interesting questions that we don't know the answer to.
So this also actually relates to one of the questions that we have here. So Andrew Powell has asked how governments can best promote good automation and prevent the so-so and bad automation. And I think it's also related to a point that Raquel made, which is like, in principle, theoretically, we could think that governments could redistribute the gains from automation, which are going to capital, redistribute somehow to society. So I think these two questions, I think if you could comment on them.
Well, actually,
together.
there are two different questions there. Let me actually start from the second one.
Mm-hmm.
I'm actually not a big fan of the view that we should let technology take its course, whatever its course is, and then we redistribute the gains. And not just because we never do the redistribution, that would be argument enough, but for two other fundamental reasons. First of all, I suspect, but I don't have solid evidence for, but I suspect that people losing their jobs and not having secure, good, high-paying career jobs actually has lots of socially corrosive effects, so that you're not going to be able to make up to damage of job loss just with simply fiscal redistribution. But second, because there isn't the course of technology. There isn't something that says, oh, this is the future path of technology. We decide that path, and there are many efficient paths, there are many inefficient paths. So it is a choice of society as a whole which direction technology takes. So therefore, saying we're just going to let technology go in whatever direction it wants and then we'll try to make up for it with redistribution, I think absolves us too much from the responsibility for redirecting it or directing it in the correct direction. So that's why that it connects to Andrew Powell's question. So then how do we redirect it? Well, I think that's a complex question. We could first of all get rid of many of the distortions, such as the one that's up on the slide now. So right now we are encouraging firms to adopt a lot of not so productive technologies because they get tax breaks for them. So leveling the playing field between capital and labor in terms of taxation would help. This isn't asking for wealth taxes or anything like that. It's just plain old corporate income taxes that companies pay. Right now they don't pay it because they have either become S corporations or because marginal tax rates have been slashed on capital holders, or because they get these amazingly generous depreciation allowances. So that's a very, very simple, going back to the tax structure of the 1970s or the 1960s would be one step. But beyond that, if you look at the history of technology, the fingerprints of the government is all over all of the defining technologies of the last century. The government did not produce these technologies, but it played a central role in this, in sort of deciding together with the private sector, together with the researchers, what those technologies were. The internet, sensors, or all aeronautics technologies, antibiotics, nanotechnologies. These were all technologies that were first supported, purchased, and fueled by government programs. Even when you come to our biggest failing, perhaps, climate change, actually, we have produced an amazing array of green technologies that are almost cost-effective with fossil fuel, thanks to a huge amount of government support for these technologies. So the government policy has never been neutral. So, and I don't see why it should be neutral when it comes to its labor implications. But how to operationalize that is another matter. You know, how we're going to decide, how we're going to measure which technologies are going to have negative externalities or negative effects through their impact on labor, which ones are the so-so technologies. That's a difficult issue. But, you know, we have to start somewhere. 50 years ago, if you said to anybody who knew about, you know, government tax policy that, you know, all OECD economies were going to subsidize technologies on the basis of their carbon footprint, they would have said, you know, that's crazy. How are you gonna measure that? How are you gonna make that operational? But now almost all countries do that. So I think we have to start somewhere.
Thank you, Daron. I think I skipped a question here. Gustavo Fernandez is actually asking about the role of entrepreneurs in this process, and is asking you to say a couple of words about it if you can.
That's a great question. I don't know. I'm sure the entrepreneurs are central. And as I said, the government did not create the internet. The government did not create antibiotics. The government did not create the sensors. Those were entrepreneurs. But they were entrepreneurs working within a framework that was shaped by government policy, social norms, and so on. And right now, there is sort of the conceit that, oh, you know, there is a particular direction that AI technology wants, and we just have to run after it, or what that technology is, only the executives of Facebook and Google know. So I think that's not the right perspective. So that's what I'm trying to sort of say. We have this endogeneity that we have to take into account. We have a responsibility, exactly just like in the green technologies, you know, many people took ownership of that, not just governments, but also consumers who said, we're not going to produce, you know, we're not going to drive cars that burn a lot of fossil fuels. We're going to recycle and so on and so forth. So it's a societal choice where technology will go.
Thank you, Daron. We're running out of time. Does anybody have an additional question? So let me just thank you, Daron, so much for this very interesting, provocative talk, and for the answer to all of these questions. It was really a great session. And let me thank again Claudio and Raquel for making this possible. And it was a pleasure to host it. And I'm sure the audience also agrees with me. Thank you so much.
Thank you, Rodrigo. Thank you, Claudio, Raquel, Elena. This was a great pleasure to be here with you. Thanks.
Thank you very much, Daron.
To the audience for the great questions.
Wow.